All right, and here we find ourselves halfway through this key concept already. We are on target to be day 2. Well, not quite halfway. After we're done with today, we will be. So we're still on determining congruence. Okay, so for your learning goals for this day, I can describe the path that would map a pre-image to an image using a combination of 2 or more transformations. I can justify whether or not the image and pre-image are congruent. Okay, and some vocabulary. Dilation. You've probably heard of getting your eyes dilated if you've ever been to the eye doctor. So it's like that. Dilation is to resize a pre-image so that the resulting image has either larger, which you would say an enlarge, or smaller, which is reduce, so that it's either smaller or larger. Dilated images are not congruent. Their angle measures are, their side lengths are not. Dilated images are similar figures. Similar figures are geometric figures whose angle measures remain congruent but whose side lengths are different yet proportional. So that means even though the image is bigger or smaller, there is a proportion between the side lengths. Not that that is going to be covered necessarily right now, but it's important to know the difference between congruent figures and similar figures. Okay, so example 1, we want to describe the path that would map the pre-image to the image using a combination of at least 2 transformations. And then we need to justify whether or not the image and pre-image are congruent. So if we look from here to here, you could say it has either been translated or, so you could just slide it, or it's been reflected over a line. Now, are the image and pre-image congruent? The answer to that is no, because one is a dilation of the other. So basically, if I were to take and I were to draw a line from the corresponding parts, if they were congruent, all of these lines would be parallel. But as you can tell, even just getting as far as I have, these are not parallel lines. And the images are clearly not the same size. However, their sides do appear to be proportional. So are they congruent? No. No, they're not. But you still have to describe the transformations that could move this image to this image. All right, so for the second example, we need to describe the path that would map the pre-image to the image using a combination of at least 2 transformations. And again, we have to justify whether or not the image and pre-image are congruent. Now for this one, this is a little bit trickier in some ways and a little bit easier in others because we've got this coordinate plane. So this grid is a coordinate plane. So we're starting over here, and if you notice, we have the prime notation down here. So we know what our corresponding parts are. So we could say, well, it looks like this is bad. So this is image is 3 away from the x-axis over here. It's 3 away from the x-axis over here. We maintain the 4 unit length on both of them. So we could say that there is a reflection, which would put it actually right here. Okay, not where it ended up. So then we would also have a translation. So it would be reflected over the x-axis and then translated to the right. And it looks like it would be, because if this was C, and this ended up being C prime, so that'd be 1, 2, 3, 4, 5, 6 units to the right. Nothing up and down. So there's a reflection and a translation. Are the figures congruent? Well, the easy way to tell that, here we have, this is 2 units, this is 2 units, this part right here is 4 units, that's 4, and it looks like we go over 1 and 2, over 1 and 2, over 1 and 2, over 1 and 2. So these are the same length, so we can say yes, the figures are congruent because the image and pre-image have congruent angles and side length. And that's all there is to this. So now we are officially halfway through this unit. Now would be a good time, if there's anything you're struggling with or have questions on, to come and talk to me before we get much farther along. Other than that, you guys have a good one.